So, additive processes in electronics production. I mainly, and you will see in my talk why I say that. So I want to speak about our view and vision of additive processes in electronics production and how we, in partnership with others, make an impact with inkjet. So how do electronic devices work? So if you look at the building blocks of electronics or electronic devices, you will see very fast that the electronic devices are made up of structured functional layers. Yeah? Be it the PI junction and oxide and metal layers in a transistor, in a solar cell, or the organic electronic layers in a OLED display, or the seemingly simple conductive and isolating layers in a printed circuit board. They're all functional, structured layers. So how are they manufactured today? They manufactured, or one of the basic process chains in electronics manufacturing today is the so-called lithographic process chain. So there is a coating process, a functional layer. This can be a vacuum coating, this can be a slot die coating, even a dip coating, or any other technology, but it's always full area. Then in the second process, you apply a edge resist, typically with spin coating or with dip coating, sometimes even full area screen print. Then you cure locally the resist with UV light. This can be done in a mask-based process or a mask-based process or a digital process like laser direct imaging or even mask aligners are used in production. Then the uncured resist is washed away, leaving you with just the resist on the local resist on the functional area. So only in step 5 you will structure the actual functional layer, which is the red one in that case, and then you strip away in the last step the resist that was put on top. So you have a 6-step process to make one functional structured layer, and you do this. You repeat this process for each layer. So this is a quite wasteful process. And did you know that according to the IPI, a large semicon fab uses up to 10 million gallons of water per day, which is equivalent to 300,000 households. This is a city of the size of Düsseldorf. So while electronics manufacturers, of course, have understood that the recycling wastewater is key to their success and further expansion, the introduction of more efficient, more sustainable process steps to create the actual functional layers is becoming increasingly important. So how to do this? So what's our vision? Wouldn't it be great if we could put the functional layers, layer by layer, just print them to get a transistor, to print a solar cell, to print an OLED display, or to print let's look a bit more into detail for the single processes. So what do we actually need to do? And I see 2 classes of applications there. So we can already make an impact by printing the resist, saving us two process steps in the lithographic process chain. It's not a lot, but it's already something, yeah, where you can make an impact. Assuming, of course, that we can print the resist, or that the actual structures that you want to get are in the area or a solution that you can't print. The goal, of course, is to print the functionalities themselves. Yeah? So this would be the class 2 applications. And I want to give you some examples where this actually has been done. So let me give you an account of OLED inkjet printing, or OLED inkjet printing in display industry. So there might be some listeners in the audience who know the beginnings of this history much better than I do, but nevertheless, let me give you a short account. In 2004-05, Cambridge Display Technology, a spin-off from Cambridge University, shipped the first OLED inkjet printers in the so-called Litrex project. So they were the foundations of inkjet printed OLEDs. In 2005, Ulvac, a Japanese vacuum deposition tool provider, acquires 50% of Litrex. In 2007, CDT, so Cambridge Display Technology, was sold to Sumitomo, and Litrex technology was bought fully by Ulvac. 7 years later, in 2014, JOLED was founded with a goal to produce inkjet OLED displays. So in 2016, if you look at the performance, and this is possibly something that goes along the lines of the previous talk, if you look at the performance of evaporated OLEDs against solution processed OLEDs, you still see the differences. I hope you can see it. So we have 17% for the red emitter, or minus 2.5% for the green emitter in brightness, and roughly half the lifetime if you compare evaporated OLEDs and solution processed OLEDs. So these are digits from 2016. Yeah? Nevertheless, this has changed over the recent years, since LG has chosen an inkjet printed OLED from JOLED in 2021 for their next generation ultra-fine OLED Pro monitor. This one here, you can look at the reference, that's the picture of the monitor. And they are using inkjet printed OLED panels. So 2021, JOLED starts mass producing inkjet printed OLED panels for display industry. So what are the takeaways? We are operating in an ecosystem of material suppliers, printed manufacturers, integrators, manufacturers, and end users. So it might take a long time to introduce additive processes, but they will prevail in the end because they're just making sense. Another example that is maybe not as prominent as OLED printing is an inkjet PCB solder mask. And this is traditional electronics in the naming of the previous talk. Nevertheless, it's something where we can print or make an impact with inkjet. How did we do that? So in 2003, Schmid and Heidelberg Instruments started a project on inkjet processes in PCB industry, where 2004, which led to the foundation of Schmid technology in 2004. In 2010, this company was making an impact with an inkjet printed edge resist process in solar industry, which was one of the biggest successes of that company in 2010. And this inkjet edge resist process, it increased the efficiency of solar cells and was adopted worldwide. In 2012, Notion Systems was founded, and shortly after that, I don't know, I don't think that Taiyo heard that, but nevertheless, it was good timing. Taiyo announced the development of an inkjetable solder mask material. So Taiyo being one of the big solder mask materials providers to the PCB industry. So in 2014, the solar crisis was at peak, and Schmid, after 150 years of company history, had to close their many subsidiaries, among them the inkjet technology group. 2 years later, around 2016, more material providers, material suppliers introduce inkjetable versions of their solder mask products. Among them, Agfa, you will see outside, Electra, Rongda, there are other suppliers around. So in 2017, after, say, 4 years of development, Notion Systems ships its first solder mask platform to Weird Electronics CBT, the first mass production solder mask platform. And in 2021, back instruments. So for us, in the year 2021, a circle closed of 17 years or 18 years. So today, we have an installed base of more than 60 inkjet platforms serving 40 different applications in semicon, optics, electronics, display, energy storage, and solar markets. It's all different applications. It's all inkjet. So I think there are more applications than just a few in printed electronics for inkjet. And today, also the adoption of inkjet solder mask is still ongoing with installations in Europe, North America, and Asia. So I want to close the history lesson with a short video. As you see, it's an automated loaded, it's an account only of how the inkjet solder mask works. It's automated loading of the PCB panels. We have an alignment, automated alignment of the whole of the PCB on both sides. Now you see the printing process. You see so the print heads are just on the right-hand side, and you will see the UV light as it shines. So it's directly printed and cured in the same process steps. Then you have a flip of the panel. So you want to print the solder mask on both sides. It's all fully automated and working in production. So just to put in another digit there, another number. So one of our clients, the Weird Electronics CBT, they made a calculation of what they. So if they replace one of their current PCB solder mask lines with one of the inkjet systems, they save a 6-digit euro number in euros per year in power consumption. And this is the only power consumption, not taking into account all the wastewater and the use of materials. So it makes sense to look at additive processes in electronics production. So what's next? Since we are here all, say, it's a family meeting, so we are all doing electronics, printing in various areas. There are many technology providers, many material providers, and the innovations or the success that I see in the different areas of applications for Notion Systems and for others, they have been enabled by innovations at material providers, at printed manufacturers, and at integrators. So it's innovations in an ecosystem. In electronics, so our main field of application, the device performance is key. So this is the driver for new applications. So it's not so much, but it's key to bring the materials onto the surfaces is expanding the process windows of our print heads. So it's all interlinked. And what I want to tell you is my main message of today is that greater process windows in inkjet will enable new applications in electronics. And I want to thank you for your innovations, because we're using them in these applications. And I'm waiting for new greater process windows in order to foster new applications. So for the ones who attended my pre-flight seminar. I want to, well, this is the Gunter hype cycle, yeah. And I want to, well, invite you to pull a bit more at the Gunter hype cycle to get a bit less of the bullshit and less of the great expectations. Let's innovate and explain to the audience, to the electronics industry out there, what we can do, and let's climb that additive electronics ladder together, one layer at a time, rather than the full step. Thank you very much for your attention.